Dear friends, hearty welcome to the online problem solving session organized by Maths Aspirants group. As you know, Maths Aspirants initially started as a WhatsApp group in 2017 by myself, and we used to organize several online programs to help the students who are preparing for different national level competitive examinations, PG and PhD entrances. As a part of the online problem solving session series, today we have a session on ordinary differential equation, and we blessed to have Dr. Himanshu with us to handle the session. Dr. Himanshu is from Haryana and did his BSc from Shahid Bhagat Singh College, University of Delhi. And he cleared IIT JAM examination and joined for masters at IIT Jodhpur. And during that MSc period, he qualified CSER, NET, GATE exams and joined for PhD at IIT Delhi. And recently, he is awarded PhD from IIT Delhi, and his broad research area is commutative algebra. I would like to express my sincere thanks and gratitude to Dr. Himanshu for accepting our invitation and agreeing to handle this problem solving session. I'm sure that this session on ordinary differential equation will be really helpful to all of you, because ODE is one of the important topic for almost all the competitive examinations. I welcome everyone to this program. Welcome, Himanshu.
Thank you, sir. Thank you for introducing me. So, I am Himanshu and I have done my PhD from IIT Delhi. So, today we are going to see the previous year questions on ordinary differential equation. So, this talk generally we are restricting ourselves to only first order PD. So, maybe in the next upcoming session we will see more on ODE that will come into the exams. So, my talk generally in this talk, I keep almost all the prerequisites that we need during the PYQs of ODE. So this is the outline of the today's talk. So first we'll start from the ODE, then we will see how we will solve the differential equation, and then then later we will see the PYQs of first order ODE. Then first, what is an ODE? So an ordinary differential equation is an equation involving an unknown function yx and its derivation. So this is the general form of the ordinary differential equation. So what is difference between ordinary differential equation and partial differential equation? So when we are talking about ordinary differential equation, then we are talking about one independent variable which depend on one variable x. So we will have an example of ODE and PD. And what is PD? PD involves partial derivative with respect to two or more independent variables. So in this talk, in this session, we are only stick to the ODE. So this is an example of ODE. So here we can see that this is an expression in terms of y and y dash and a function of x only, in which y is dependent on x only. So this is first order ODE, and here this is an example of PD. In this, u is a function which depends on x and t, that involves partial derivatives. Now what is the order of an ODE? So the order of an ODE is the order of the highest derivative present in the equation. So for example, we have this differential equation d square y by dx square plus 3dy by dx plus 2y equals to 0. Here we have differentiated y 2 times. So this is an ODE of order 2. See, I am saying ODE, that means the variable y depends on x only. Later we will now we will use the terminology differential equation, since we will talk only ordinary differential equation. Now, what is the degree of differential equation? Ordinary differential equation, it is the highest power of the highest order derivative after removing any radicals or fractions. For example, consider this ODE. d square y by dx square raised to the power cube plus dy by dx plus y equals to 0. So the highest order derivative is d square y by dx square. So now the power of this derivative is 3. So the degree of this differential equation is 3. Now, what are general solution and particular solution? So whenever we have a differential equation, then we want to see the solution of differential equation. Generally, the ordinary differential equation or partial differential equation is occur from many applications. You can follow any book for the application point of view, how this differential equation occurs. So in this session, we only focus only towards the solution, which is important from our exam point of view. So now what is general solution? So general solution of an ODE contains the complete family of solutions, which involves arbitrary constants. This arbitrary constant depends on the order of ODE. Now what is particular solution? So a particular solution is obtained from the general solution by assigning specific value to the arbitrary constants, which may be given in the form of initial or boundary value solution. Sorry.
Excuse me,
Is it-
dear participants, please unmute, please mute your mic. I think it's because of some echo, I think. You can go now.
Yeah, sure. So now let's see an example of general solution. So I have just taken a solution of this differential equation dy by dx equals to 2y, yx equals to c e raised to the power 2x. So this solution contains the arbitrary constant c. When we see the solution that passes through some point, say y x equals to 0, we obtain the value y equals to 5. Then this general solution has the particular form yx equals to 5 e raised to the power 2x. Initially, one can look that the general solution is a family of curves. Here c e raised to the power 2x is a family of curves. For different value of c, we have different value of curve. So when we pass it through a particular point, then it will become a particular solution. So in upcoming slide, we will see when we have a differential equation, then we get a unique solution, no solution, how many solutions we will have. So in the questions also, we will see when we can say a differential equation has a solution. If it has a solution, then it will be a unique solution, or it has more than one solution. So all these questions we will address in upcoming slides. So now we have existence and uniqueness theorem. Consider the first order initial value problem dy by dx equals to fxy, which passes through the point x0 and y0. So now when the solution has unique and when the solution will exist and it has a unique solution. So when this function fx comma y is continuous in some region that contains this point x0 and y0 and its partial derivative with respect to y is continuous, then the solution of this differential equation will exist and it will be a unique solution. Let's understand this theorem by an example, then later we will see some questions on that also. Before that, let me give you some idea. Here the continuity of fxy ensures that the slope field is well defined. So we know that whenever we are talking a first order differential equation dy by dx refers to the slope of the differential equation, slope of the solution function. So the continuity in the first condition, here fxy is continuous in some rectangle around x0, y0. This ensures that slope field is well defined. However, the continuity of del f by del y prevents solution from crossing. Like if we have two solutions, then if del f by del y is continuous, then two solutions at the intersection point won't cross. So this implies one initial condition implies unique curve. I think you have some idea why we are having this type of condition geometrically. So if any one of you have any issue understanding this, then please ask. Okay, then we move forward. So let's have an example of existence and uniqueness theorem. So I have a differential equation of this form dy by dx equals to x plus y with the initial condition y0 equals to 1. That is, the solution curve is passing through 0, comma 1. Now see that this function fx comma y equals to x plus y. This is continuous everywhere. Similarly, the partial derivative of this fx comma y is 1, which is also continuous. So this has a unique solution for all x. In this, till now we have not solved this differential equation. So without solving differential equation, we have this much information. So this information, when we have a complex function fx comma y, then before finding whether we have a solution or not, this theorem really helps us a lot. Now let's consider another example in which we have more than one solution. So consider this differential equation dy by dx equals to square root of mod y0 with the initial condition y0 equals to 0. Note that the fxy is under root of mod y, which is continuous everywhere. However, one can compute the partial derivative of y when y is greater than 0 and y is less than 0. Then we have the term in denominator. Then at y equals to 0, this partial derivative will not be continuous because it should continuous in the domain which contains 0, 0. But at y equals to 0, del f by del y is not continuous. So in that case, we cannot say about existence and uniqueness theorem. Moreover, we can see that when we substitute y0 equals to 0, this will be a solution. And when we substitute yx equals to x square by 4, then it is also a solution. So this differential equation has more than one solution.
Sir, why dy by dx is not continuous at y equal to 0?
You can consider the domain when y is greater than 0, say, then it is root y. Then f of xy is under root of y. Then just take the partial derivative, it will be 1 by 2 under root of y. Is it clear?
No, sir, I didn't understand.
Otherwise, you can use the definition of partial derivative limit, that limit definition. Is it clear?
Sir, can you explain more one time of definition of?
So, what is the definition of del f by del y? So, it is limit. I don't have pen and paper right now, so maybe I can speak orally. So, the definition of del f by del y is limit y tends to 0. So, we are looking at the change in y, which is f of x comma y plus del y minus f of x comma y divided by del of y, where del y is tending to 0. So consider this and take two direction, then you will see that this partial derivative is not continuous. So just try to do it. If not, then at the end we will discuss it again.
Okay, sir.
Now we will see how to solve our first order differential equation. So in general, it is not easy to find a solution for first order ODEs. So we have differentiated differential equation in different characterization. So depending on the form of differential equation, we will see the solution of differential equation. So first we will see the first order linear differential equation. So a linear first order differential equation is of the form y dash plus pxy equals to qx. So what is the solution for this type of differential equation? So first we will write the differential equation in its standard form y dash plus pxy equals to qx. Then we will find the integrating factor. Now what is the integrating factor of this differential equation, which is u of x equals to exponential raised to the power integration of px dx. Now the solution of this differential equation is given by this, which is mu of x, which is integrating factor, into y equals to integration of integrating factor into qx dx plus c. Then later we can divide by ux to get the final solution. Now what is Bernoulli equation? A Bernoulli equation is a first order differential equation of the form y dash plus pxy equals to qx y raised to the power n, where n is not equals to 0 and 1. Note that for n equals to 0, this is a linear ordinary differential equation when n is 0. And when n is 1, then we can separate the term of y and a function of x to get a separable ordinary differential equation. When n is not equals to 0 and 1, then it is non-linear Bernoulli equation. So now how we will solve this Bernoulli equation? In this we will do the substitution v equals to y raised to the power 1 minus 1. Then our differential equation is converted in this type of differential equation, which is a linear first order differential equation. So let's have an example of Bernoulli's equation. So we have a differential equation y dash plus y equals to y square. Here px is 1, qx is 1, and n is 2. So we do the substitution v equals to y raised to the power 1 minus n, which is 1 minus 2, which is equals to 1 by y. Then we do the differentiation and then substitute this value in our given differential equation. Then we substitute, then we get this type of differential equation, which is dv by dx minus v equals to minus 1. So this is first order linear differential equation and we know how to solve it. So we compute the integrating factor. Here px is 1, so integrating factor is e raised to the power minus x. Now we multiply it by integrating factor into v, then integration of integrating factor into minus v plus c. So we will get our solution v e raised to the power minus x equals to e raised to the power minus x plus c. Then later we will substitute the value of v as 1 by y and we get the final solution in the relation of y and x. Now what is the exact differential equation? So a first order ODE in this form mxy dx plus nxy dy equals to 0. We say a differential equation is exact if we have a function phi x comma y, which we can write it in the total differentiation and equate it such that d of phi xy equals to 0. So a differential equation of this form is exact if we have a function phi such that d of phi equals to 0. Now how we will solve this exact differential equation? So this differential equation is said to be exact if and only if del m by del y equals to del n by del x. So one can see the proof in any standard book of the ordinary differential equation. So we are now looking into the proof of the exactness. So what are the steps to solve the exact order differential equation? So first we will check whether a differential equation is exact. So we will compute the partial derivative del m by del y. and del n by del x. We check whether the equality of this equation will hold or not. Then if differential equation is exact, then we have a function phi. Now when we do the total ordering, then del phi over del x is equivalent to mx comma y, and del phi by del y is equivalent to nxy. So we can choose any of the function. Here in this I have chosen del phi over del x equals to m. Then I have integrating it with respect to x, and we get a function of y. One can choose another function and do the integration with respect to y and get a constant function in the term of x. Then just solve this differential equation, we will get the function phi of x comma y. So I will just explain this in the form of an example. So here consider this differential equation 2xy plus 3 dx plus x cube plus 4y dy equals to 0. Here m is 2xy plus 3, n is x cube plus 4y. So I have one remark here. So whenever we are given a differential equation, just before solving your question, just make sure that it is given in the standard form. Otherwise, there is a chances to make a mistake. So here the standard form is m dx plus n dy. So m is 2xy plus 3, n is x cube plus 4y. So we compute the partial derivative of m with respect to y, which is 2 of x, and partial derivative of n with respect to x is 2x. So now we have considered this del phi over del x is m. So we integrate with respect to m. So when we integrate it, we get x square y plus 3x plus gy. Now phi y is equivalent to n. So phi y is x square plus g dash y. So we get g dash y equals to 4y and gy equals to 2y square. So we substitute the solution gy in phi of xy and we get this solution. So when you see many other books, then there are many other formulas which consider that whenever you are doing, there are standard formulas for that also, in which we are assuming that second integration is with respect to free of x and free of y. So my suggestion generally, I prefer by doing it the whole process, which gives the correct answer. So now what is homogeneous function, and then we will see the questions on, we will see an example of homogeneous differential equation as well. A function fxy is called homogeneous of degree n if for any lambda greater than 0, f of lambda x comma lambda y is equivalent to lambda raised to the power n f of x comma y. When n is 0, then fxy is homogeneous of degree 0. Then so generally our function, we can write it in the form of phi y comma x or psi x comma y depending on this. So why we are writing this? Because we can make this substitution v equals to y by x or v equals to x by y to convert our differential equation. So now what are homogeneous differential equations? So we have a first order ODE of this form dy by dx equals to fx comma y. Then when fxy is homogeneous of degree 0, then it is a homogeneous differential equation. So our fx comma y is converted it into either phi of y divided by x or a function of psi x by y. So what is the method of this? So if our function is in the form of y by x, then we will make the substitution y equals to vx. Then differentiate it and substitute the value of dy by dx and y in our main equation, and then solve the differential equation. So it will come out to be a separable variable equation. So this is an example, dy by dx equals to x plus y divided by x minus y. So in this, I divided it by x in the right hand side, then make the substitution v equals to v equals to y by x. Then dy by dx is v plus x dv by dx. Then substitute this dy by dx and y by x. We will get this differential equation, and it's a separable variable equation. Just do the integration on both sides. We will get our solution as tan inverse y by x minus 1 by 2 log x square plus y square equals to log mod x plus y. So this is the theory part that requires for the PYQs. So till now, if anyone has doubt, please ask. Then later on, we will see the questions.
Hello, sir. Sir, you told me about the particular solution and general solution. I want to
Yes,
know.
yes.
I want to know about the singular solution and how to find the singular solution.
Singular solution generally when we substitute the solution in the differential equation. Generally, singular solution when our existence and uniqueness theorem fails, then we will see what kind of solution we will have. So maybe at the end I will give you an example in which we can we will look what solution we have at the end. I will give an example. So from that, I think that will be more helpful to make
Okay,
it
sir.
clear.
And so I have another doubt. So in existence
Yes.
and existence and uniqueness of the solution. So I read about the lipstick condition. This
Yes.
lipstick condition, that both are same or different.
In first order PD, then it won't make that much difference. But when we talk about second order PD, second order OD, then we will talk about Lipschitz continuity. Here also, I have taken del f by del y as continuous. For this, I can, I don't want to write it Lipschitz continuity because I don't know whether the audience are familiar with that or not. So here, that's why I'm keeping it del f by del y is continuous. But we can change it to the Lipschitz continuity as well.
Okay, sir.
Okay, so let's start with the question. So it's a Jan 2016 question. So it's a 2 marks question. So for each question, we will have a pause of 1 minute so that you can see the question and you try to solve it on your own. So we have consider the differential equation sin 2x into dy by dx equals to 2y plus 2 cos x with the initial condition y pi by 4 equals to 1 minus root 3. So we have the 4 options. So we are asking about the solution is unbounded when x tends to 0. Solution is unbounded when x tends to pi by 2. Solution is bounded when x tends to 0. And solution is bounded when x tends to pi by 2. So can anyone tell me how we can proceed this question?
So first we have to make in a standard form.
Yes. So first we will make it into a standard form. So we will divide it by sin 2x. And then we will solve the differential equation. So we have divided it by sin 2x. So this is a linear differential equation. So first we will compute the integrating factor. So here our px is minus 1 by sin x cos x. So our integrating factor will come out to be cot x. Then we will multiply integrating factor y into cot x, integration of cot x into 2 cos x divided by sin 2x, and then we integrate it. So we will get the solution y equals to minus secant x plus c tan x. Now we will substitute our initial conditions. Y of 5 by 4 equals to 1 minus root 2, and then we will calculate the value of c, which later comes out to be c equals to 1. So we have this solution y of x equals to minus 1 plus sin x divided by cos x. So now we will calculate the limit when x tends to 0 and x tends to 5 by 2. So when x tends to 0, it is minus 1 plus 0 divided by 1, which comes out to be minus 1. So when x tends to 0, our solution is bounded. When x tends to 5 by 2, it is a form of 0 by 0. So we will use the L'Hopital's rule to calculate the limit. So we will differentiate it, and then we check the limit when x tends to pi by 2, it comes out to be 0. So in both the cases, our solution is bounded. So our option C and D is correct. Earlier I have not talked about integrating factor. So how many of you are not aware of integrating factor? Is there anyone who don't know what is integrating factor of differential equation? So whenever we have a differential equation of the form m dx plus n dy equals to 0. So when this differential equation is not exact, that is del m by del y is not equals to del n by del x, then if we multiply it by a function of x and y, then after multiplying our function is exact, that function from which we are multiplying, it is called an integrating factor. So now we have this question: if x raised to the power h, y raised to the power k is an integrating factor of the differential equation given by this, then the order pair h comma k is equals to. So this is the question. So how you will calculate it? See, it is given that differential equation from the order pair there is no h equals to 0 and k equals to 0. So we don't have to check this differential equation is exact or not, because clearly we can see that this differential equation is not exact because there are no option of 0, 0. So in this, we will multiply it by x raised to the power h, y raised to the power k. So our differential equation, it will convert into this form where our new m tilde is given by x raised to the power h, y raised to the power k, plus x raised to the power h plus 1, y raised to the power k plus 1. Similarly, we will have n tilde. Then here in this new differential equation, n tilde dx plus n tilde dy equals to 0, we will check the exactness condition. So we will calculate del m tilde by del y and del n tilde by del x. Then we compare the same coefficient terms. So we will compare the coefficient of x raised to the power h, y raised to the power k, and x raised to the power h plus 1, y raised to the power k plus 1. So we will have a relation of K and H in the system of linear equation. We will solve this and we will get the value of K and H. So we will get the value of H is -2 and K is -2. So option A is correct. So it's a very simple question. So let's proceed to the next question. So it's a Jan 2020 question. So in this question, we are given u equals to x cube and b equals to y square. So we have to transform the differential equation 3x raised to the power 5 dx plus y square plus x cube dy equals to 0 to an equation of the form dv by du. So try this question and tell me what is the solution of this. So after a minute, we will see how to solve this. So any guesses how we can do this, how we can solve this question?
First, we will find dv by du, then by comparing.
Any other guess?
So firstly, you differentiate u in term of x and v in term of y, and then we can substitute the value of du by dx in given equation, and also substitute the value of u in given equation, maybe.
Correct. Any other possibility? Okay, let's see the solution on this. So we are given u equals to x cube and b equals to y square. Then we compute the du and dv and substitute the value in the given differential equation. Solve it and rearrange the values in u and in the form of u and v. We will get dv by du equals to -2u divided by u plus v. So we will have our option A. Now it's a 2023 question. So consider the initial value problem dy by dx plus alpha y equals to 0, where y of 0 equals to 1 and alpha belongs to R. Then which of the following option is correct? There is an alpha such that y of 1 equals to 0. There is a unique alpha such that limit extends to infinity yx equals to 0. There is no alpha such that y of 2 equals to 1. And there is unique alpha such that y of 1 equals to 2. Yes, so how we will solve this question? Yes, so we will solve the differential equation or any other approach. See, when you don't know how to do it, so we have a differential equation in our standard form. So it's a separable variable equation, we can solve it. So when we solve this differential equation, we get y of x equals to c e raised to the power minus alpha x. Now we are given the initial condition y of 0 equals to 1. Substitute it and then get the value of c. So our particular solution is y of x equals to e raised to the power minus alpha x. So now we have y of x equals to e raised to the power minus x. Then we can now see all the solutions and check which of the followings are correct. So now we substitute y of 1 equals to 0. Then our left hand side is e raised to the power minus alpha, which is never 0. So option A is incorrect. Now take the limit x tends to infinity. Since our alpha belongs to R, so our solution varies. So it depends on the value of alpha. For any negative alpha, this B part also fails. Now substitute y of 2 equals to 1. In this case, alpha equals to 0 has exactly one solution. So this also fails. When y of 1 equals to 2, we get a unique solution, alpha equals to minus log 3. So our option D is correct. Now let's see, go to the another question. So for the differential equation, y into 8x minus 9y dx plus 2x into x minus 3y dy equals to 0. So in this we are asked which of the following options are true. So the differential equation is not exact and has x square as an integrating factor. The differential equation is exact and homogeneous. The differential equation is not exact and does not have x square as an integrating factor. The differential equation is not homogeneous and has x square as an integrating factor. So in this question, we ask two different things. First, we want to see whether this differential equation is exact. It is homogeneous. And third one is x square is an integrating factor. So by looking at the differential equation, is this homogeneous?
Yes, sir.
So can I? So one can see that this is an exact differential equation. So we can either divide by y over x, then we will have a function in the form of y by x or x by y. Now to check whether this differential equation is exact, so our m is y into 8x minus 9y and n is 2x into x minus 3y. So we will compute the del m by del y and del n by del x. So is it coming out equal or not?
Not equal.
So when we compute del m by del y and del n by del x, so it won't come out to the same. So this differential equation is not exact. Now we will multiply this differential equation by x square. So we have new differential equation of this form 8x cube minus y minus 9x square y square dx plus 2x raised to the power 4 minus 6x cube y dy equals to 0. So to this differential equation, we will again compute del m tilde by del y and del n tilde over del x. So when we differentiate it with respect to y, we will get 8x cube minus 18x square y. Similarly, del n tilde by del x, we will get 8x cube minus 18x square y. So now this new differential equation is exact. Hence this x square is an integrating factor. So our option A is correct. The differential equation, the original differential equation is not exact, but after multiplying by x square, the differential equation will become exact. So now let's go to the next question. So in this question, for alpha belongs to R, let y of alpha x be the solution of the differential equation dy by dx plus 2y equals to 1 divided by 1 plus x squared, which satisfies the initial value problem y of 0 equals to alpha. Then which of the following is true? So we are asking, so they have asked to compute the limit when x tends to infinity for every alpha belongs to R, and option C and D says there exists an alpha belongs to R such that limit x tends to infinity y of alpha x exists, but its value is different from 0 and 1. There is an alpha belongs to R for which limit x tends to infinity y of alpha x does not exist. So again, we will solve this differential equation. So integrating factor is e raised to the power 2 dx, which is e raised to the power 2x. We solve the differential equation. Now in this, when we are solving it, the integrating by e raised to the power 2t divided by 1 plus t squared dt, it's very difficult. So when we compute the limit, we will apply the L'Hopital's rule. So one can easily check that we will get limit x tends to infinity y of alpha x equals to 0 for all alpha belongs to R. So in this question, we need to do little bit calculation. So try to do it on your own. Now let's go to the another question. So it's a latest question of Jan 2025. The question is, let phi is the function which is the solution of differential equation x dy by dx equals to log y minus log x y. Satisfying phi of 1 equals to e square, then the value of phi of 2 is equals to. So how we will solve this differential equation? Can anyone tell me? Yes.
Sir, we divide the equation by x.
So this type of differential equation, this is,
And this is this will be linear equation maybe.
how it will be a linear equation. We have an expression of the form log y.
Okay, sir.
So this expression is log y minus log x.
We can substitute y by x by v, and log y minus log x, we can write log y by x. Then it will become log v.
Yes, so from this we can do it. So is there any other thing that you have observed in this question? So is there any symmetry in the solution of this? So what kind of solution we have? E square, 2e raised to the power cube, 3e square, 6e cube. Something e raised to the power 2x, e raised to the power 3x. Anyway, let's solve this question by substitution. So here on the right hand side, we have log y minus log x. So which can be rewritten as log y by x. Then we make the substitution y by x equals to v. Then after substitution, it will be a separable variable differential equation. We will solve it and we have our equation v equals to e raised to the power 1 plus c1x, which again can be written as y equals to x e raised to the power 1 plus c1x. Now we substitute the given condition phi of 1 equals to E square, we solve it and get the particular value of C1. So we have our solution y equals to x e raised to the power 1 plus x. Then we substitute phi of 2 equals to 2 into e raised to the power 1 plus 2, which is 2 e cube. So we will get our solution. So our correct option is D. So now we have a question of JAM 2025. So if phi be a solution of differential equation, dy by dx equals to y minus 1 into y minus 3, satisfying phi of 0 equals to 0. So we don't have any right hand side. So this is a separable variable differential equation. So we divide by y minus 1 and y minus 3 and solve the differential equation, integrate it, and then check the limit when x tends to infinity, x tends to log root 2, x tends to minus infinity, x tends to log 1 divided by root 2. So whichever option is satisfying, we will get our solution. So I hope, I think we can skip this question. You can see the solution in the video later. So now we will have some previous year NBHM question. So I have observed that the first order differential equation questions in NBHM, I think it's very, well, I believe that it is very easy. So in 2015, they asked this question, use the change of dependent variable z equals to y minus 2. So the differential equation x y dash plus y equals to x raised to the power 4 y cube. So which type of differential equation is this?
Bernoulli.
Yes, so it's a Bernoulli equation. So we make the substitution z equals to y raised to the power minus 2 and solve this. So depending on our domain, we will get the solution y of x equals to plus minus 1 divided by x into root 3 minus x squared. So this is our solution before substitution. I hope this question is clear. We can move to the next question. So again, this is a simple question. Solve x plus y dx equals to x minus y dy. So which type of this question is? Is it linear, separable? So what kind of sorry?
Substitution we can apply.
Yeah, so this is a homogeneous differential equation.
Yes.
So again, we can write dy by dx in the form of x plus y divided by x minus y. Then make the substitution y equals to vx or x equals to vy and solve this differential equation. So we will get our final solution as tan inverse y by x equals to 1 by 2 log x square plus y square plus 2. So I'm just skipping this intermediate calculation that we can verify on the right. Now we have a CSA of December 2015 question. So it's a 3-mark question. So in this question, let yx be a continuous solution of initial value problem y dash plus 2y equals to fx with the initial condition y of 0 equals to 0 and fx is given by this function. So this is a linear first order differential equation. So how will calculate y at 3 by 2? Any guesses how we will do this question? Yes, any guesses?
First, we will calculate particular integral. Then, it is asking value at 3 by 2. X is 3 by 2 means if x we will take 1. Then we will find general solution.
Yes, so here our function, it's a step function. So when we solve this differential equation in the following interval from 0 to 1 and 1 is 1 to infinity, then our function y we will get is 1 by 2, 1 minus e raised to the power minus 2x and yx equals to a e raised to the power minus 2x. Now the function is differentiable, so this function is continuous at x equals to 1 also. So we will use this extra information to calculate the value of arbitrary constant a, because the initial condition is only given at x equals to 0. So using the continuity at x equals to 1, we will calculate the value of a and we will have our solution when x is greater than 1, and then we will substitute the value of x equals to 3 by 2 to get our solution. So is this clear?
Yes, sir.
Sir,
Okay, so yes,
how to find the y of x value?
find the value of,
Y of x.
find the value of a.
Y of x, sir. Y of x equal to 1 by 2, 1 minus e power minus 2x.
Huh. So are you talking about this, that y of 3 by 2 equals to this? How we will get this in the term of?
Sorry, sir. The second line for 0 less than or is equal to x less than or is equal to 1. Y dash plus
Yes.
2y.
So here this we have the differential equation, linear, first order linear differential equation. So we have integrating factor e raised to the power 2x. Then using that method, we calculate the value of yx as 1 by 2 into 1 minus e raised to the power minus 2x using this initial value, y of 0 equals to 0. That's why in this yx is free from constants.
Okay, sir.
Yes. Then later, since this function satisfy our differential equation, so it will be continuous at x equals to 1. Then at x equals to 1, using this function and this function in point 2 and 3, we will compute at x equals to 1 and find the value of a. Okay, then now let's go to the next question. So this is again December 2015 question. It's a 3-mark question. So in this, we have given an ODE on our y dash x equals to fy of x. So our right hand side f is a function of y. So if f is an even function and y is an odd function, then which of the following is true? Minus y of minus x is also a solution, y of minus x is also a solution, minus yx is also a solution, and yx into y minus x is also a solution. Please do this question and tell me which option is correct. So we have to substitute these functions in our given differential equation and check whether left hand side and right hand side is same or not. Yes. Have anyone done this question? Okay,
B.
so let's take. Sorry,
B option is correct.
which one?
B.
B.
Yes.
Yes. Anyone else?
Sir, option A.
Sir,
Yes, sir, option
Yes.
is.
So let's see. So when we substitute minus phi of minus x, let's put into our differential equation. So when we substitute it, it is we will minus y dash of minus y of minus x when we substitute in this differential equation. So we have y dash of minus x equals to f y of minus x. So now the function is here our function y is an odd. So y of minus x is again y. So we have the same right hand side. So in this case, when option A is there, then we have the only case where left hand side is equals to right hand side. Now why option B is false? Because when we substitute in this, here y of we differentiate it, then we will get minus y of minus x in the left hand side, and in the right hand side we will get f of y of x. Because y is an odd function, then y of minus x is minus y of x, and f of minus of yx is fy of x, because f is an even function. Similarly, we can check the option C and D and check that the left hand side is not equal to right hand side. Now let's see this question. Generally, I have seen that this question is repeatedly coming in both JAM, NET and GATE exam. So this is a question of a particular form. So let k be a positive integer and consider the differential equation dy by dt equals to y raised to the power 5k plus 5k plus 2, where t is greater than 0 with the initial condition y of 0 equals to 0. Which of the following statement is true? It has a unique solution which is continuously differentiable on 0, infinity. It has at most two solutions which are continuously differentiable on 0, infinity. It has infinitely many solutions which are continuously differentiable on 0, infinity. It has no continuously differentiable solution on 0, infinity. Yes, so how we will proceed this question? Here we are talking about unique solution and about the existence and uniqueness of the solution. So can we apply the existence and uniqueness theorem here? Yes, anyone? So our differential equation here is of some particular form. So dy by dt equals to y raised to the power alpha, where alpha is 5k divided by 5k plus 2. So whenever alpha is strictly lies between 0 and 1, this function y raised to the power alpha is continuous, but its partial derivative is not continuous at y equals to 0. So here existence and uniqueness theorem fails. So we will solve this equation And one may observe that this solution has infinitely many continuously differentiable solution satisfying our initial value condition y of 0 equals to 0. So we will shift our solution on the right hand side by a constant b, and we will get our this solution y of 2. So this is the standard question that you can see in any of the book, and many of the times in exams this question appears. So sometimes it is taken as a result when alpha lies between 0 and 1, this solution satisfying IVP y0 equals to 0 has infinitely many solutions. So here our option C is correct. Now let's see some gate questions. So it is a gate 2008 1 mark question. Let y be a solution of y dash equals to e raised to the power minus y square minus 1 on 0, 1 which satisfies IVP y0 equals to 0. Then we are asked about y of x greater than 0 for x greater than 0, yx less than 0 for x greater than 0. Y changes its sign in 0, 1. That is, it is positive in some interval and negative in some interval. And y is identically 0 for x greater than 0. It's a very nice question. So how you will do this question? So this question you can solve it without using pen and paper. So just see the question, and whatever we have done, one can guess that the answer of this question. Yes, anyone can tell me how we will do this question? Any idea how we can proceed? So what will be your first step?
So variable separable form.
How you will do it? So can we integrate this e raised to the power minus y square, this term?
So if we write it as 1 by 1 minus e power y square by e power y square, and then you shift it to the left hand side and let t is equal to e power y square minus 1. And then we write all of it in terms of t with log. So then we can solve it.
Just try it. I don't think so. You can integrate it very easily.
Okay, then we try some.
Yes. Any other idea? Okay, so let's see the solution on this. So here note that our function f of x comma y is e raised to the power minus y square minus y of minus 1. Also, we are given the initial value condition, which is y of 0 equals to 0. So what we will do is, we use the existence and uniqueness theorem here. So one can see that, one can check that the right hand side our function f of x comma y e raised to the power minus y square minus 1. This is continuous also, and its partial derivative with respect to y, which is minus 2 of y e raised to the power minus y square, which is also continuous. So from the existence and uniqueness theorem, we have a unique solution. And also one can observe that when one substitute the solution y of x equals to 0, on the left hand side we have 0, and on the right hand side also we have 0, is the solution of this differential equation, satisfying the IVP. So this option D is correct, because we have a unique solution from the existence and uniqueness theorem, and this is the solution of our given differential equation. Is it clear? So this is what I have written here. So here dy by dx is e raised to the power minus y square minus 1. So our f of xy is e raised to the power minus y square minus 1. Our function fxy is continuous, and its partial derivative with respect to y is also continuous. Also, we can verify that y equals to 0 is the solution. So from existence and uniqueness theorem, this is the only solution of our given differential equation. So option D is correct and other options are incorrect. So is this question clear?
Yes, sir.
Any doubt in that?
No, sir, clear.
Okay. Now let's move to the next question. So it's a GATE 2011 question. So the question asks the initial value problem x dy by dx equals to y plus x square when x is greater than 0 and y of 0 equals to 0. Has infinitely many solutions, exactly 2 solutions, a unique solution or no solution. So before doing this question, can you tell me, can we apply the existence and uniqueness theorem here? Because in this question we are asked about whether we have a unique solution, no solution, or more than one solution.
So first we divide by x, then we can get
So
dy by dx.
yes, it's not in a standard form. So we have first to make it into a standard form, we will divide it by x. So when we will divide it by x, then x should not be equals to 0. But in initial condition, we are given y of 0 equals to 0. So here we cannot apply the existence and uniqueness theorem because function is not continuous. So we will solve this differential equation. So we will divide it by x and then solve this differential equation. This is the first order differential equation. First order linear differential equation. So we solve it. We have the integrating factor u of x equals to e raised to the power integration of minus 1 by x dx. When we solve it, we will get integrating factor as 1 by x. And we compute the general solution. We get y equals to x square plus cx. Then apply the initial condition. And we can see that the initial condition is free from the value of c's. So for all the values of c, we have this solution. So there are infinitely many solutions of this differential equation. So option A is correct. Let's move to the next question. Let y be the solution of y dash plus y equals to mod x. X belongs to R, y of minus 1 equals to 0. Then y of 1 is equals to. Yes, so how we'll do this question? Any guesses? So it's a similar type of question that we have done earlier. So we will divide our problem when x is greater than 0 and when x is less than 0. So the right hand side, when x is greater than 0 is x and x is less than 0, it is minus x. So we have two differential equations now. Y dash plus y equals to x and y dash plus y equals to minus x. So we will solve this differential equation and using the continuity at x equals to 0, we will calculate the value of y at 1. So is it clear how we will solve this question?
Yes, sir.
So this is the solution of this. So we make two cases when x is greater than equals to 0 and x is less than 0. Then we use the continuity at x equals to 0 to find the particular solution and then substitute the value to calculate to get our correct option. So we will get option A. So I'm not doing this calculation. Please verify it on your own. Now we have a question from GATE 2018. The general solution of the differential equation xy dash equals to y plus root x square plus y square for x greater than 0. So what type of differential equation this is?
We can substitute y by x by
Yes. So
v.
again, this is homogeneous differential equation. We will divide it by x and then make the substitution y equals to vx. So make the substitution y equals to vx. Then we will get our differential equation x v ds equals to root 1 plus d square. So this is a separable variable differential equation. Solve it and get the value. So we will have our solution kx square equals to y plus root x square plus y square. So here option C is correct. Now let's move to the next question. So it's a GATE 2024 question. So in this, if y1 and y2 are two different solutions of ordinary differential equation y dash plus sine e raised to the power x y equals to cos e raised to the power x plus 1, then which of the following is its general solution on the interval 0, 1? Again, it's a very easy question from GATE. How we will do this question? Yes. Any guesses?
So this is a linear differential equation of first order.
Yes. Then
First we will find the integrating factor.
how we will calculate the integrating factor? So if we try to calculate the integrating factor, which will be e raised to the power integration of sine e raised to the power x. So it will be a very tedious calculation if we will calculate the integrating factor. Any other observation?
Sir,
Okay, let's look.
Bernoulli,
Yes,
Bernoulli equation.
it's not a Bernoulli's form. We don't have any y raised to the power terms. So clearly it is a first order linear differential equation. Note that on the right hand side we have only function of x only. Okay, let me give you a hint. In the option you can see that there is nothing in the term of x. So they have written the solution in the form of linear combination of y1 and y2.
Variation of parameter.
No, there is no need of variation of parameter. Tell me one thing, if y1 satisfies the differential equation, here we are given y1 and y2 are two different solutions. So that means y1 and y2 will satisfy the differential equation. Yes
And so
or no?
both solutions linearly independent, sir.
Sorry. See here, there is nothing given about initial value problem. So for example, for a given differential equation, a e raised to the power x is a solution. For different values of a, we have different solution. So for now in this question, we are given only y1 and y2 are two different solution of the given differential equation. Right? So that means if y1 and y2 are two different solutions, then y1 and y2 will satisfy this differential equation. So now we are asked about which of the following are general solution. So we can substitute and check whether C1y1 plus C2y2 is a solution of the differential equation or not. Yes or no?
Yes, sir.
So when we substitute y1 in the differential equation, we have y1 dash plus sine e raised to the power x, y1 equals to cos e raised to the power x plus 1. So this is what I have done here. So I will substitute y1 and y2 in this differential equation. Then the right hand side is free from y1 and y2. I just subtract it. Now it's a differential equation in the form of y1 minus y2. Now use the separable variable and solve it. We have this differential equation. Another way of doing this is a very simple way. Just take the option C1y1 plus C2y2, put this into this differential equation, check whether the left hand side equals to right hand side or not. So in this only one option will come out to be correct, which is option B. Similar thing I think we have noticed in vector spaces also. So something convex combination type of this maybe you have seen or. So the question idea is similar to that one. So you can just substitute this general given general solution and check whether they satisfy the differential equation. So this is it from my side. So
Okay, thank
there is
you.
one.
Yeah.
Yeah, so there is one question that I have to tell about that singular solution. I think I have a similar kind of example there. So generally, singular solution are those solution when we compute through our analytical method for any value of C, we won't have that solution. So let me see. So here look into this solution. So this is one differential equation. So generally singular solution are those solution when we put any particular value of C, we won't get that solution. So geometrically, this solution can be looked as envelopes in the form of the solution space, and when we will look at the tangent, so this kind of solution are called singular solution. So whenever we solve a differential equation and we have for the arbitrary value of C, we have okay, let's look at this question. So we have x dy by dx equals to log y minus log xy. So we have solved this question and we get our solution as y equals to x e1 plus c1x, right? So for any value of C, we won't have yx equals to 0 as identity function. Then substitute the value of y equals to 0 in left hand side. Our left hand side is 0, and when y equals to 0, then y equals to 0 identically, it is also a solution of this differential equation. We are skipping this initial value problem for now. But here, for any value of C1, we don't have y equals to 0 as a solution. So whenever we are solving a differential equation and we have some other solution which is not seen from our computations, then this type of solution are called singular solution. So this is another way of looking at these singular solutions. I hope this gives you an idea like what are singular solutions.
Good evening, sir. My name is Varada. I have completed my BSc and right now I'm preparing for JAM. So I truly enjoyed today's session. Since I'm preparing for JAM, I've been like less exposed to questions from GATE, NET, and etc. till now. So since you discussed questions from that as well, I really got an idea about how things will be in that as well. So yeah, I would say that it was very enriching session. So thank you so much, sir, for providing us such a wonderful session. And thank you, Vinod, sir, for organizing this class.
Thank you, Varada.
Hello,
Others?
sir. Good evening, sir.
Yeah.
Sir, I'm Archana. I have completed my BSc. So I really enjoyed your session, sir. Like I like how you went through the maximum number of questions and all the questions were prepared before itself. So it allowed us to have maximum questions in very less time. So I enjoyed the session, sir. Sir, is it possible if you could get the PDF or the presentation?
Yes. Sure,
Okay,
I
sir.
will share it with the sir. Sir will share it with him.
Okay, sir. Thank you so much, sir. Thank you, sir. Thank you, Vinod, sir, for organizing the session.
Okay, thank you, Archana. Any others?
I think many of them already have gone because I think it's a dinner time.
Yeah. Because in almost all the for hostel students, this may be the right for the time for the dinner.
Yes.
Yeah. Okay, anyway, at the beginning, we have more than 70 participants. And
Yes. Sir.
towards the end, many issues as it is a Sunday, data issues may be there. Okay, anyway, we will provide the recording of the session. Okay, thank you, Himanshu. We can plan the second parts of.
Hello, sir.
Yeah.
Hello,
Yes.
sir.
Yes.
Yes, I am 𝐻𝐫𝐝 Malik from Jharkhand. I completed my MSc from the State University. Now I am preparing for CSR NET exams. So, sir, this session will very helpful for me for discussing the PPSC question paper. Sir, this session will very helpful for me. Thank you, sir. Thank you, Himanshu, sir.
Yeah. Thank you, Abhijit. All the very best for your preparations.
Thank you, sir.
Okay, I think we can wind up now. Once again, thank you, Himanshu, for taking all this effort to make all the slides and all that.
No, sir, thank you so much. I push also myself forward making all those things. So it's a very good experience for me as well. So generally, I try to make my slides students friendly so that any audience can understand it. So maybe next session we will have some more good questions
Okay.
because first order differential equation is very difficult to get different varieties of questions. So maybe next session we will have really more and very good questions.
Okay, that's good. So please do share the
Sir,
PDF.
one more thing. Sorry, sir. Sir, one more thing. How can I join with Himanshu, sir? Please, sir. How can I join? Please, YouTube link or any other.
See, for the future sessions, we will share the details in our WhatsApp group.
Okay, sir.
And
Sorry, sir, I am not in your WhatsApp group, sir. Please, sir.
You see in the chat, I have pinned one message. There my number is available. You can message me into that.
Okay, sir. Thank you, sir.
You can just go through the chats. You will see at the top. It will be there.
Okay, sir. Thank you.
So anyway, Himanshu, once again, thank you very much. Please do share the PDF of these slides. We can share it along with the recording of this video.
Sure, sir.
Okay, once again, thank you. Thank you, everyone.